So we're using the product rule on each function to find the derivatives of these two functions. We call one of them h of x and the other r of x. Let's go ahead and do that. If you haven't done that yet, make sure you pause the video and do it on your own. H of x is equal to 7x to the fourth e to the x. And again, it's the product of two functions. The first function is the 7x to the fourth, or let me write that a little bit nicer, 7x to the fourth. And the second function is e to the x. Now, I probably should say the second expression, not the first function. The first expression might be a little bit more accurate. We have one algebraic expression, which is 7x to the fourth, and it's multiplied by a second expression, which is e to the x. So just for the notes, let's take, and we'll set that one equal to the f. We'll set the second expression equal to the g. Now, when we have that, we can look at derivatives. So f prime will be equal to 28x to the third, and g prime is equal to e to the x. So our function h is going to have derivative, which is the derivative of the first expression, which is 28x to the third, times the normal second expression, which is e to the x, plus the normal first expression, 7x to the fourth, times the derivative of the second expression, which is e to the x. And there you go. So that's the derivative of h of x. Some people will rewrite this. Some people won't write the multiply signs in there. They'll just put an implied multiplication in. Sometimes you'll see people try to factor out a greatest common factor. So each term has an e to the x in it. Each term has 3 factors of x. Each term has a factor of 7. So sometimes people will rewrite this after they factor out the greatest common factor. They'll say 7x to the third e to the x times 4 plus x, or something of that sort. I honestly prefer it, if you're writing things in Moodle, to write it this way. So I tend not to factor after I've taken a derivative using the product rule. Okay, we won't be as explicit on the second problem. We take the first expression that I see there, 8x to the fifth, and my second expression is going to be natural log of x. This means that the derivative of r will be the derivative of the first expression, 40x to the fourth, times the normal second expression, natural log of x, plus the normal first expression, 8x to the fifth, times the derivative of the second expression, 1 over x. Derivative of natural log is 1 over x. This one I do tend to clean up things like this, I do tend to multiply that x to the fifth times 1 over x and get x to the fourth. But I don't factor out. So I take 40x to the fourth times the natural log of x plus 8x to the fourth. So once again, I tend not to factor out a greatest common factor. You could factor out an x to the fourth and an 8 here in both terms, just like we could factor out an x to the third and a 7 and an e to the x up here. So I tend not to factor out things, but I do multiply things like x to the fifth times 1 over x. Or if I had numbers, I would multiply coefficients if I had those. So that's how we take the derivative of those two functions. You don't have to each time write down what the first expression is and what the second expression is, but sometimes people find it really helpful with the product rule to write those things down.